We're into day 4 here now, and we're looking at sine and cosine again, but we're going to be looking specifically at finding side lengths, either the opposite side or the adjacent side, depending on if we're going to be looking at a sine ratio or a cosine ratio. And then, of course, the more complex one where we have to get the hypotenuse. So when we're trying to find the hypotenuse, we'll have to get that off the bottom of the equation. And then, of course, we'll do a couple of word problem examples and do some practice. This is section 2.5 in the textbook, and it closes up all three primary trig ratios, finding sides and finding angles. Then we get into basically generally looking at in 2.6, combining all three things together and finding sides or angles depending on what we need, and even adding in the Pythagorean theorem. And then in 2.7, it really starts to look at problems that have more than one triangle in them, so that you have to do multi-steps, and then that'll be the unit kind of. So today we're going to focus on sine, cosine, sides. So the first and most easiest is if you have an opposite or an adjacent side to solve. So I will do an example here. Let's draw a triangle here. Okay, so let's say this is our triangle, and we want to find the opposite side of this angle. So let's say that angle A is, let's make that skinnier, is, that looks like 24 degrees. And we know that this here hypotenuse is measured at 307 millimeters. And we want to find x. Find x to the nearest millimeter. Okay, not too difficult if we know that this is our right side. So we're going to go ahead and label everything up in here. Okay, so if we're going to label this up, this is this angle that we're dealing with, is A. So this is our opposite side, and this is our hypotenuse side. So opposite and hypotenuse, okay? So SOHCAHTOA. Okay, so opposite and hypotenuse, sine. Okay, so we're going to go sine 24 equals x, which is our opposite side, over 307. Okay, so we have to get x by itself. So the easiest thing to do here is to multiply by 307 on both sides. So we got 307 times the sine of 24 equals x. Okay, so we're going to have to get the sine of 24 on our calculator. So make sure your calculator is in degrees before you start, DEG. Okay, this is an opposite side, so there's no zero there. So this is 307 times sine 24. So I get 0.4067. Okay, and I'm going to multiply that number by 307, and I get 124.86. So I'm going to go 125 millimeters. Okay, so that's an example of finding using our sine value and finding an opposite or adjacent side. If I would have said on the same diagram, if I would have said, let's say we'll do this one in green. I would have said W is down here. Find W, course, we could do Pythagorean theorem now that we know this one, but let's just use the cosine ratio instead. So we know that cosine of 24, right, because it's still a, that's going to be the adjacent side over the hypotenuse. Okay, so if we were trying to find that, we would use adjacent over hypotenuse for the green part. Okay, so if we're looking at that one, if we wanted to find that one, we're going to do the same thing we did over here, except we're going to be using a different ratio because we're trying a different side. So we're still multiplying by 307 here, but it's going to be cosine. 307 times the cosine of 24. Let's figure out what that is. The cosine of 24 is 0.9135. Okay, so that when we do that, we would get, let's see here, times by 307, I get 280. So this would be 280. So there's an example of doing cosine sine where you have to find the adjacent or the opposite side. Not too complex, but a little bit there. You got to make sure you get the right trig ratio. Don't push the wrong button or anything like that. Be careful of that. Okay, so what about if you have to do the hypotenuse? Those ones are got the extra step of having to get the hypotenuse off the bottom. So we'll flip ahead and we'll do one like that. So let's draw a triangle here. Okay, and let's say that I know that this angle here let's say that we want to find, this is our x value, and that we know that this angle here is 76 degrees. We'll just call it angle K for now. Okay, and we also know that when we measured this bottom here, this was 26.3 centimeters from there to there. And the question is, find x to the nearest tenth of a centimeter. Okay, not so difficult, but a little more difficult than the last one. So we're going to have to figure out what we're doing in terms of our side. So we know, okay, this is our angle that we're dealing with. This is our right angle here. So this must be our hypotenuse. Okay, and then this one's touching the given angle. So touching the given angle gives us the adjacent side. And that's opposite, which we're not dealing with in this particular example right now. So we know that adjacent and the hypotenuse. Okay, so if we look back at an acronym, adjacent and the hypotenuse is cosine right there. Okay, so we're going to do cosine of 76 is equal to the adjacent side over the hypotenuse, which is going to be our x value. Okay, so the x is on the bottom of a fraction, so we've got to get it off that bottom of a fraction before we can actually do a solve here. So we're going to multiply that out on both sides to get it off the bottom on that one side. So that's going to be x times the cosine of 76 on the left side, equaling 6.3 on the right side once we cancel that x out. Okay, now we know we have to get the x by itself, so now we got to do that extra divide again. So this divide is cosine 76 on each of these. And we're left with x is equal to 26.3 or 26.3 over the cosine of 76, which I'm going to plug into my calculator at this time. So cosine of 76, make sure your calculator's in degrees. So I'm going to do cosine of 76, and I get 0.2419, okay? Don't be skimpy on the decimals with this. Go at least 3, at least. I always go 4 when I'm doing this, because back in the old days, when we didn't have scientific calculators handy, we had to look them up in the back of our books, and they always went down to 4 decimals. Okay, so let's plug this into our calculator now. 26.3 divided by 0.2419 equal 108.7, or we'll say 109. 100, or not 109, yeah, 109. I guess we should go to the nearest tenth because we have a tenth in that other one. So 108.7 when I round it, centimeters. Now, does it make sense that it's quite a long side? Yes, because it's a hypotenuse. And if the diagram's got some scale to it, it looks correct in this case. Okay, so I'm going to do another one here, let you try it, and then we'll do a word one for a problem, and then I'll give you some practice. So let's do one more here. Let's say we have this triangle here, like a ramp. Okay, so let's say, oh yeah, so let's see. All right, there we go. Okay, so let's say we have this ramp type thing here. And let's say that we now know that this angle here let's use this one here instead. Let's say that this one is 79. Actually, I did the big one last time. I'll do the small one this time. So let's say that this is, let's go 19 degrees. Okay, and we'll call that angle A on the bottom there. And we want to find this length of this ramp if we know that it's raised up say it got raised up 1.04 meters. Okay, and we want to know the length to the nearest hundredth of a meter this time. Find W. To nearest hundredth. Okay, so go ahead, try that one. I'll slide this up and work it out here. You can pause it and try it on your own if you want. See what you get. Okay, so we're looking at this one. We're going to go ahead and do this analysis. Can't talk today. Okay, analysis would be, we're looking at this bottom angle. So this is our opposite side, and this is our hypotenuse. Okay, so that's sine, opposite over hypotenuse. Okay, sine 19 degrees. What's the opposite side? 1.04. What's the adjacent, what's the hypotenuse side? W. Okay, so we have our solved problem here. We multiply W to get it on the other side so that we don't have it on the bottom of a fraction. So then that would mean that W sine A, or 19, which is sine A, but we want a number in there, is equal to 1.04 meters. So we're going to divide out sine 19 on both sides. Okay, so if we're doing that, we're going to get W is equal to 1.04 divided by whatever this sine 19 works out to be. So sine of 19, 0.3256. Okay, so hopefully I didn't make any mistakes in the first few days here now that you're doing it online. Well, you know, you never know though. Okay, if I did, hopefully you mention it to me. So this is going to be W equals, okay, so we're going to take this number and we're going to divide it by 0.3256. So I get 3.19 meters, 3.194, so 3.19 meters, and that's the length of this particular W hypotenuse. So that kind of takes us through calculating a hypotenuse, calculating an adjacent or opposite side using sine or cosine. So it could be either one. So then the last thing we want to do is the ones where you have to kind of calculate your value based on a triangle that you have to come up with on your own. Book mostly draws most of them out, but that'll be a little bit different. They do have applying stuff here, but we'll do one where example here where you have to do that as well. So let's flip ahead again here. This will be our last example for this video here. And then we'll go into doing some practice, but we're about 17 minutes in. So it's not too bad. Like I said, we want to keep it to about half a class of instruction, half a class of work when we're doing our online unit here for our grade 10. Okay, so let's go ahead and do an example. Let's say that we have, let's go, a golfer is 265 yards directly south of a hole. So she's on the tee box, looks directly south and sees that she's 265 yards directly south of a hole. The clubhouse is directly to her east. Okay. And we're going to say, what is the distance from the golfer to the clubhouse if the angle along the golf, if the angle, let's say, yeah, we'll go this way. If the angle along the line of the golfer and clubhouse. Okay, no, that's not going to work. If the angle, let's call it between the clubhouse and flag, so if centered on the clubhouse, that's the way to put it. Centered on the clubhouse to the hole is 29 degrees. Question mark. Okay, so let's go ahead and do our drawing here. Okay, so we're going to do, here's our golfer sitting here. Here's our hole, and here's the clubhouse. So this is the clubhouse, this is the golfer, and this is the hole. Okay, so if we draw that, let's use some straight lines here. Okay, making them direct here. And then this one here. What? Okay, so not the golfer to the club. What? I gave you that. What is the distance from the hole to the clubhouse? Let's change this. Sorry, guys. We already did golfer to the. Oh no, golfer to the clubhouse. No, that'll work. That'll work. That'll work. Sorry. Okay, so we know that this is 90 degrees here. Okay, because she's directly south of this hole, and then she looks directly to the east and sees the clubhouse there. Now it says the golfer is 265 yards directly south of the hole. And it also says, what is the distance of the golfer to the clubhouse? This one right here. If the angle centered, if the angle centered on the clubhouse to the hole is 29 degrees. So centered on the clubhouse, 29 degrees. There we go. Okay, so this is a word problem, and it's going to use sine or cosine, obviously. Now we're not having to find the hypotenuse, so it'd be the simpler type here, but we should start by identifying our sides to see what we need to use. Okay, we're centering on the clubhouse, so this is our opposite side, and this is an adjacent side. So I should have said so this is actually tangent, right? This is our hypotenuse. So let's change that. What is the distance from the golfer from the hole to the clubhouse? So that we got to find the hypotenuse instead. We don't want to use tan. We did that a couple of times ago already. So let's just switch that one around from the hole to the clubhouse. Okay, my mistake. I want to use sine or cosine, not. So then we're going to change this as well here. Okay, we want to find this distance. That's our x. Okay, so we've got this one and this one. This one's not given to us. So we're going to go opposite over hypotenuse. That's sine 29 degrees equals, okay, we've got opposite over hypotenuse. So we do have to use the more complex one because we want to get the hypotenuse. So multiply it by h on both, or x on both sides. Too many variables here, boys and girls. Let's keep it with the x because I put an x in there. You could put an h in there too. It wouldn't matter as long as you kept it the same. Okay, so then we're going to multiply by x here. So x sine 29 equals 265. Okay, and then we're ending up with dividing by the sine of 29. Okay, and we're going to end up with x is equal to 265 divided by whatever this sine 29 turns out to be. Sorry, I got a little messed up with the word problem here. We almost were trying to do a tan one there, but we want to do a sine or cosine one today. Okay, so let's go sine 29 to get our decimal number, 0.4848. And then if we divide 265 by 0.4848, oops, 265 divided by 0.4848, we get our 500 and, let's go to the nearest yard, 547 yards. Okay, so hole to clubhouse is 547 yards. Okay, my apologies there for changing a couple words in there as we were making up the problem, but we wanted to do a sine or cosine one. So that leaves us with practice. Okay, considering we're at about 27 minutes, we're not doing too bad. So the practice on this one is page 101 and 102. Okay, and I'm going to give you 3AC, 4AC, 5AC. Okay, those are all drawn for you. And then 9 as a word problem. Since I went a little long today, I'll go 6 and 9 for the 2 word problems. Like that, 9 and 6. Okay, that's lots, okay? And you can work on that. And that's our 4th day. Apologize for a little slow word problem, but hopefully it did not confuse anybody.